Okay, so let's graph these points. So if we graph -1, 2, and then 0, 1, yikes, it's bouncing around on me, and 1, 1/2. If we were to graph a couple other points, what you would notice is that this graph goes about like this. So asymptote still, once again, at y is equal to 0. All right, so we graphed this first graph, this y equals 2 to the x, and looking at it, we decided that was growth because it was going up, right? So if we look at this graph, the 1/2 to the x, looking at the graph, we realize this is definitely decay. But I want you to be able to look at the equation and recognize whether or not it's growth or decay. And we have some more information about it on the next page, but I want to mention it here also. Okay, so the key is looking at what I refer to as the B term. That's the base number that the x is attached to. So whatever that base number is that the x is attached to, if the base number is greater than 1, it's going to be growth. If the base number is between 0 and 1, it's going to be a decay. Okay, so that's that 1/2, that's a fraction between 0 and 1. So if we get a fraction that's between 0 and 1, we've got decay. If we've got a number that's the base that the x is getting raised onto, if that's greater than 1, then we know that it's growth. Okay? All right, and I'm going to actually jump down here because we've kind of looked at this already. So let's go ahead and answer these questions. It says, does the graph ever touch the x-axis? And we know that's a no. The type of boundary line that this is called, you still keep seeing these asymptotes, don't you? Okay, so we're going to write the equation of that as y is equal to whatever the number is. So for the basic graph, it's going to be y equals 0, but we're going to look at some where we're shifting up and down, left, right, so that's going to change. So the equation is going to be of the form y equals that number, right? Okay, question so far? Oops, do I have one more graph there?
Yeah.
Okay, yeah, I definitely want to look at that one too, because I want you guys to think about what's going to happen there with that negative out front. So if you notice, the base for this is the same as this first graph was over here. So in terms of writing a table, it would be the same points. So it would be -1, 0, 1. I'm using my basic points. We're going to deal with the negative here in a minute. So for my basic 2 to the x graph, go back and look at what I had over here, right? It's 1/2 and 1 and 2, okay? Only now we've got to deal with this negative out in front, and the way we deal with that is that we take those y values that we have and we're going to multiply each of these by -1. Okay, so this is going to be -1/2 and -1 and -2. So those are the points we're going to graph. So we're going to graph -1, -1/2, 0, -1, and then 1, -2. And let's get this asymptote in here. So that negative out in front reflects that graph. Do you see that? Hopefully you can visualize the fact that that's getting reflected over that x-axis. Okay. All right. So let's kind of look at, we've got some properties, kind of some things to think about and talk about that hopefully you've picked up on here. A lot of this information is the same for both graphs, right? They're really the key to pick up on is the fact that, okay, if we've got growth, We know this is going to increase as we go from left to right. It's the b value here. The b is greater than 1 that helps us decide that that's exponential growth. And then for this one here, where we see the exponential decay, it's that it's going down here, and it's the b value here once again. If you look at all of this information down here, all of that's the same for all of them, for both, whether we're talking growth or decay, okay? Domain's gonna be the same, the range is gonna be the same, continuous graph, all of those types of things, okay? So the key is just kind of focusing on this. B is greater than 1 for the growth, B is between 0 and 1 for the decay. All right? Okay, so we do need to talk about, though, how we are going to make these shifts and deal with all of that. All right, so let's kind of talk about this. Let's focus our attention on this first graph. We're doing y is equal to 3 to the x. That's going to be our parent graph. So we want to think about that graph, and we want to do our table of values for that graph, and then we want to decide how we are going to be shifting or changing the graph. So let's do our table. So -1, 0, 1. So 3 to the -1. We know that we're flipping that, so 1/3. Okay, so there's our table. Those are our points that we're going to graph, that we're going to draw in. What is different about this graph here that we're looking at here? What is this telling us we have to do? We're gonna, we're shifting which direction? Left 1. Okay, it's attached to the x, so it's gonna be left or right, and it's opposite sign, right? Okay, so left 1 means, I always like to draw in what I refer to as like my new starting point, my new crosshairs, where we're starting from. So that shift there tells us we're shifting left 1, and that's all we're doing. That's where my new crosshairs is. From that new starting point is where I'm going to graph these points. So from this, I think of this as my new origin. That means I'm going to go left 1 and up 1/3. And then I'm going back to the origin, and I'm going up 1, and then from there I'm going right 1 and up 3 to help me draw that graph. So it looks very similar to what we already had in those other graphs. It's just getting shifted a tiny little bit to the left. Yes, you still have to label that asymptote. Okay, so get into that habit very early on. Okay. All right, that was growth. What do we know about this one? Growth or decay? Decay. Okay, so we know it's decay. What is this shift telling us we have to do? Down 2. Okay, so that's going to change our asymptote also, isn't it? So y equals -2. So we do want to make sure we put that in, okay? But when we when we do our table of values, I want to do the table of values for y is equal to 1/3 to the x. That's my parent graph, and then we'll deal with the shifting, okay? So for that table, -1 and 0 and 1. So 1/3 to the -1 gives us 3, 1 and 1/3. Here's my new crosshairs. Here's my new starting place. My new origin is shifted down 2 units. And so now from here, I'm going to go left 1, up 3. I'm going to go up 1, and I'm going to go right 1 and up 1/3. Boom. Okay, questions, guys? All right. Try this one yourselves. I'll go through it in a minute, but try this for yourselves. You have the points over here already for your y equals 3 to the x. That's the parent graph. Think about how you're shifting and doing all of that, okay? I want to get this video, make sure that it's queued up for you guys. Because my computer's been doing wonky things here today. All right, so someone talk me through this. Josh, talk me through this one. So how's it shifting?
Left 2.
Okay, so left 2 and
Down 1.
down 1. Okay, so asymptotes at y equals -1. And we're going left 2, down 1. So there's our new crosshairs. I'm filling in these points.
Yeah.
Okay, so now what?
G across -1.
Okay.
1/3.
Okay, so from this new spot, I'm going left 1, up a third. Okay,
And then from that spot, just up 1
up 1.
from the origin.
Yep.
And then
Well, from our new origin,
Yeah.
right? Okay.
then to the right 1.
And up.
Up 3.
There you go. And then drawing that curve, that ski slope is what I like to think of it as. Okay. All right, the video that I'm going to share with you here shortly has to do with E. We're going to talk about and look at how we graph a graph using E also. In this particular, in our notes, what we've put here is kind of more a calculus way of thinking about how to derive E. So I'm going to show you a little bit simpler way of thinking about it. So this is kind of the fancy calculus way of thinking about it. But the main thing I want you to know and think about and remember is the fact that E is a number. It's kind of like pi. E is a number that is used in a lot of applications for financial and business type applications. That's where we find E primarily. But E is a number, and it is approximately equal to this 2.71828. So that's the part of it that I'm going to want you to remember is this 2.71828. Okay. So we want to kind of think about how we would graph the graph of y equals e to the x. And it's going to look very similar. E is a number, and it's greater than 1, so it's going to be exponential growth. If we're looking at a table of values here, let me change colors here. If we're looking at a table of values for y equals e to the x, if we do our table of values here, we get -1, 0, and 1. I want to talk about this 1 over e. Because a lot of people kind of freak out and are like, how am I supposed to figure out what 1 over e is? Well, we can just do an approximation, especially because we're not being really precise with how we're drawing in these numbers here. So think about the fact that E is it's 2.71828, so it's close to 3, right? So when you're graphing it, you're gonna graph it at around 1/3, okay? If you were to plug into your calculator and figure out what 1/E is equal to, there's an E button on your calculator, and I'm not talking about in the alphabet, I'm talking about the E key. Where is it? It's right above the parentheses. So just to the left of the number 1 is your E key. Okay. But to approximate and to do our graphs, we can just plug in, we can think of it as, it's about 1/3, because it's 1 over something that's close to 3, okay? So yes, this graph looks very similar to what most of these other graphs have looked like. It's not gonna be that different. But it is important to kind of distinguish between those, okay? All right, so once again, asymptote there at y equals 0, okay? All right, question, are you guys ready to try a couple of these, or do we need to talk through? There's a couple of these I want to, and then we'll be done. We're not doing all of these. I'm thinking I want to practice with this one, and this one, and this one for sure. On my notes that I'm going to post on Canvas, I will have all of them there, but we're going to focus our attention on those. So, do you want to try these yourselves, and then we'll go over them?
Yeah.
Okay, that's what I would prefer. So, all right, you do that.